Okay, let's start solving equations. In our first example, we have x plus 4 equals 11. We want to solve for x. And I know that for most of you, when you look at this expression, you're saying, yeah, I know that I need to add 7 and 4 to get 11. I don't really need to do anything fancy here, which is great. What I'm trying to do with these examples is I'm trying to give you a structure that you can then apply to more complicated problems. So this is the thought process that I would like for you to have when you're looking at these. So you see an equation, and you see how there's an x, and there's something happening to x, right? It's not just x sitting there by itself. If your equation was x equals 11, you'd say, well, duh, I already solved the equation x equals 11. But the idea here is that x is not by itself. So we have to answer the very first question, and that is, what is happening to x? What is happening to x? Well, 4 is being added to x, right? So the answer is 4 is, I'll just say, added to x, okay? 4 is being added to x. Now, the thing is that we don't want anything to happen to x. We really want to get this to a point where x is by itself. So since 4 is being added to x, the next question is, how do we undo that, right? How do we undo that? And when we say, how do we undo that, it's always that we do the opposite. Well, like for example, if I took 3 steps to the right, how would I undo it? Well, I would take 3 steps to the left. So since 4 is being added to x, the way to undo it is to subtract 4. Now, what does that mean? What it means is we have 4 is being added to x. This is what's happening on the left side. We are going to subtract 4 to undo that. Are we allowed to do that? Sure we are, as long as, if you remember from the previous video, we also subtract 4 from the right side, right? We subtract 4, and it's always from both sides of the equation. Now, adding and subtracting 4, of course, cancels each other out, leaving you with x, and 11 minus 4 is 7. There is our answer. X equals 7. This is really the process that I would like for you to use when you are working on solving equations. At the very least, these one-step equations. You really want to say, what is happening to x? How do I undo that? And then follow through. Let's take a look at the next example. X minus 7 equals -3. So what is happening to x? Well, 7 is being subtracted from x. Well, what's the opposite of subtracting 7? Well, adding 7. So what we want to do is we want to add 7 to undo the subtraction. And that means that we have to add 7 on the right because we did it on the left. Whatever we do, we have to do to both sides. Negative and positive 7 cancel. And we have x equals negative 3 plus 7, which is 4. Let's take a look at another example. 4x equals 28. Well, what is happening to x? Well, x is being multiplied by 4. Remember, if there's no sign in between, it means there's multiplication. Well, how do we undo multiplying by 4? Well, what is the opposite of multiplying? It's dividing. So what we want to do is we want to divide both the left and right side of the equation by 4. Well, multiplying by 4 and divided by 4 cancels each other, leaving us an x. And 28 divided by 4 equals 7. The answer to the equation is x equals 7. Let's do one more example. X over 3 equals negative 5. Again, the first question we ask ourselves is what is happening to x? And here x is being divided by 3. Well, what's the opposite of dividing by 3? The opposite of dividing by 3 is multiplying by 3. So we are going to take x over 3 and we will multiply by 3. We want to undo the division, and that means we also have to multiply negative 5 by 3. Well, dividing by 3 and multiplying by 3 cancels. You can also think of 3 as 3 over 1 and you do the cross canceling, but either way you have x equals negative 5 times 3, which is negative 15. And so there is our answer, negative 15. Now, as you go through the steps of solving these equations, it's not difficult to make a silly mistake. Happens all the time, happens even to us professors. And there is a way to check if you did your work correctly, right? If your answer is correct, for example, if you look at the first example, x equals 7 is correct. If I plug 7 in for x, 7 plus 4 should equal 11, which it does, right? That is your check. Or here we said the answer is 4. Well, that must mean that 4 minus 7 equals negative 3, which, if you think about it, it does. Or here we said x equals 7. That means 4 times 7 is 28, and it is. Or in the last problem, if x is negative 15, if we plug that in for x, well, is negative 15 divided by 3 negative 5? Yeah, 15 divided by 3 is 5, and negative over positive is negative, so it does work. It's not a bad practice when you solve an equation to check your work by just plugging your answer back in for x and seeing is the expression true. In the next video, we're going to look at 2 slightly more complicated examples.